Hello. Right now we're getting ready to look at even and odd functions. So I thought this time that we would just go ahead and look at the formal definition and then work some problems. So looking at our definition, we have a real valued function f is even if f of opposite of x equals f of x for all x in the domain of f, and it's odd if f of opposite of x equals the opposite of f of x for all x in the domain of f. And you say, wow, that sure is confusing. Well, it is, but I think as we work some problems, it'll clear up for you. So let's do that next. We're going to determine whether a function here is even, odd, or neither. It might not fit either definition. So notice in the definition it talked about f of opposite of x. So that's where we're going to start, with f of opposite of x. So that means I'll put empty parenthesis cubed minus empty parenthesis to the fifth, put in an opposite of x. Since I've replaced x in the f of x with opposite of x, I'll do so everywhere. So f of opposite of x equals, if I say negative times negative times negative, I still have a negative. So that's minus x cubed, minus in the problem, and then I raise minus x to the fifth, and I have minus x to the fifth. So f of opposite of x equals minus x cubed, minus a minus is a plus, plus x to the fifth. Now, does that equal our original f of x? No, doesn't have the same signs. So that implies that this is not even, because to meet the test of even, I would have to have f of opposite of x right here the same as our original f of x. Well, let's try factoring out a -1 and see if it fits the definition of odd. So we have x cubed minus x to the fifth. Check it. Minus 1 times x cubed is minus x cubed. Minus 1 times minus x to the fifth is plus x to the fifth. Now, let's see if that is the opposite of f of x. Well, in the parentheses here, is that f of x? It is. And it has the opposite out here and here. So that implies that it is an odd function here. All right, let's move to the next slide and do another one. F of x equals 3x squared minus x to the sixth, and see whether it is even, odd, or neither. Well, again, we start with f of opposite of x, because that is the starting point. And then we see if f of the opposite of x is either f of x or the opposite of f of x. So 3 empty parenthesis squared minus empty parenthesis to the sixth, plug in an opposite of x, and here when I raise a minus to the second power, it's plus. So I have 3x squared minus in the problem, then raising the minus x to the sixth, I get x to the sixth. Now I'm going to look and see if I've gotten f of x back. Is this the same as this? Sure. So that implies we have an even function. Let's do one more of these even odd ones. And let's try this one. Determine whether this one is even, odd, or neither. Same start we've had. Put in opposite of x. So empty parenthesis squared minus empty parenthesis to the fifth. Put in opposite of x. And we get that the f of opposite of x equals x squared minus a minus x to the fifth, because when I raise a negative to the fifth power, it's negative. So on the next line, I'll take care of my double negative there and get x squared plus x to the fifth. And then I'll look to see if it equals f of x. Is this the same as this? No. So it is not even. Well, let's factor out a negative 1. So negative 1 times opposite of x squared minus x to the fifth. Let's check it. Negative 1 times negative x squared gives me positive x squared. Negative 1 times negative x to the fifth gives me plus x to the fifth. Let's look at this right here. Is that equal to opposite of f of x? Well, the opposite's there, but is this f of x? I look and it's not. So no. So it is not odd. If it's not even and it's not odd, it must be neither. Now notice something here. When I plug in f of opposite of x, I do not always get minus the original function, do I? So be careful there. Don't think that you're always going to get opposite of the original function, because we've seen two cases, one where it was even and one where it was neither, where that didn't occur. Only the f of opposite of x turned out to be minus f of x when it was an odd function. Okay, that concludes our odd, even, or neither functions.